Hey kids, we're having a good day. Today we're going to talk about vertex array objects. So last time we did vertex buffer object which held the data in GPU. And now we want to bind this data to attributes so that we finally can get some triangles happening. So attributes, let's see, attributes. Attributes are whatever context-dependent data we wanna associate with each individual vertex. So it might be stuff like position, seems like a pretty important one, and it might be color or normal and so on. These are called attributes. And what we're gonna do today is that we're gonna bind these attributes to specific portions of the data. So we're saying like, okay, this data over here is the position, maybe this data over here is the color, and however they are arranged among however many different vertex buffer objects. And all of this, all the attributes and their bindings, like so, is controlled by the vertex array objects. Or the VAO. All right. So let's make one. Whoops, spoilers. I might have done this a little bit off stream. All right. So let's do vertex array objects bindings from buffers to attributes. So the way we generate an array object is very similar to how we generate a buffer. We call glgen vertex arrays. One. So we're going to want to generate one vertex array, and again, it's expecting a pointer to a GLU int, which is the handle again. So we're not getting any structs or objects or classes out of it. We're just getting a handle, just an integer representing that vertex array. So again, we'll make a GLU int here. We'll do a VAO. And we'll say that. So now this is going to generate one vertex array for us and put it in this VAO integer. Great. And just like buffers, functions that work with VAOs are expecting you to have one bound at a time. So you're going to have to bind a VAO, call functions that work on the VAO, then maybe bind another one, call those same functions again for that one. So you can only have one bound at a time. So we'll do GL bind vertex array. And this time there's only one type of vertex array, so we don't have to specify the type or anything. We just crank in our VAO right there. Like that. And now, so now we have a VBO bound or buffer with data. We have our VAO bound. So now we're going to have to start defining some attributes. Let's just not go too crazy here. We only want a position this time. So we don't care about color or normals right now. We only care about position. So the way we define attributes is that we give them an index, all right? So it might be, okay, so index 0 is position, and index 1 is color, and index 2 is normal, and then so on. We can do whatever we want here. It makes maybe the most sense to do them sequentially, so do 0, 1, 2, 3, and so on. Usually I put position at 0 because it's the most important one. So we'll say, okay, attribute 0 is gonna be our position. That's what we decide here. So we have to enable it. So we're going to tell OpenGL that I'm going to enable an attribute at index 0. So we'll do GL enable vertex attribute array. Now, there's a little pitfall here because there is a function called GL enable array attrib, which takes 2 parameters. I think this one also binds the VAO. I actually don't know because it takes the VAO there. But this is the thing with OpenGL, that is sort of, layers upon layers upon layers, that there are many functions that seem very like each other, but maybe do very different things. So be careful, double check your function calls to make sure you're actually calling what you think you're calling. So we're going to enable this vertex attribute array then, and see what does it take. It takes index. So this is then which index attribute we want to enable, and we want to enable index 0. It's going to be our position. By the way, I highly recommend this website here, chronos.org. You don't have to go, you can just pretty much just Google a function name and it will take you to the official Chronos documentation, which is very good. It's quite thorough in explaining all the different inputs, what they mean, and so on. So don't feel like you have to memorize all of these functions, because I sure have not. Like, for example, GL vertex attribute pointer. So what this function does is telling OpenGL how we're mapping the data in the buffer object to this attribute. And now is the time where we decide sort of, okay, is it a vector? Is it just a float? Is it an integer? Is it an integer vector? Like, what's the data and what does it mean? In our case, we have 2 components per vertex, so it's a vector 2, and they're the position. So let's type that in then. So first is the index, and this is which attribute are we working on, and we're working on attribute 0, the position. Size, so size can mean a lot of things, and in this case it means how many components are there per attribute. So if it's 2 integers or 2 floats, or 3 integers or 5 floats or whatever. So the size in our case is going to be 2. All right, so we have 2 floats per vertex, and then type is which type it is. So in our case, it's going to be float, and type means then like what data type it is a float or integer or so on. Here's normalized. So that is if it should normalize the data for you. I've never actually tried putting it to true. I just sort of normalized them myself. But in our case, a position, we don't want that to be normalized, so let's just do false. Stride and pointer we will get back to. So just for now, just put 0. We will get back to those. What those actually mean. Great. So now we've enabled our attributes and we've bound it to our buffer. And important to note here, when you call this function, this GL vertex attribute pointer, it's important to remember which buffer is bound right now, which buffer is enabled, because that's the buffer that the VAO is going to remember the binding to, right? So if I forgot to bind my buffer before calling this vertex attribute pointer, then it's undefined what's going to happen. It's undefined what buffer it's actually going to bind to. Likewise, it's important to remember which VAO is bound, when calling this function, because that's the VAO that's going to remember that binding. So otherwise you might get bind attributes on a different VAO because you forgot to bound it, or so on. So important stuff. Great. Okay, so let's draw it. Okay, so let's do the draw call here. I don't think I'm gonna go into a lot of details about what we're about to do just yet. I'm just gonna do it just so we get something on screen. So we do GL draw arrays, and for the mode we're gonna do triangles because we want to draw triangles. And then first is just which vertex is the first one, so we're just going to do 0 and then count is how many vertices we're going to draw. Don't worry about it, there's too much yet. I'm going to go into more detail later. For now, just trust me on this. And then we hit F5. Okay, so I have a triangle on my screen. You may or may not have a triangle. I think it depends a little bit on what version of OpenGL you are on, because we have not, if you remember from the video, the pipeline video, there's a lot of steps we forgot about. The whole shader bit we haven't even done yet, we haven't even mentioned it. what I think is happening is that on some OpenGL versions, it will just use a default shader that takes the first attribute, like on attribute 0, and treat that as the position, and then just do white pixels, and that's it. So hopefully you're seeing a white triangle right now. If you don't, it might be because you did something wrong, but if you don't, it might also be just because your OpenGL version is just old. Maybe it's newer, who knows? Maybe mine is old, and that's why it works. So I just wanted to show you so some of you get some sort of hope that I'm not just like telling you to type stuff that's just random. Like we have a point to this. But yeah, so that's Vertex array objects. What they do, they handle this stuff. So next time we're gonna actually start writing shaders. All right, so see you then.